Today we are going to discuss about count of leaf nodes in a binary tree. First of all, we should know what is a leaf node. Leaf node is a node which is not having any children. Leaf node is a node which is not having any children. We need to count all leaf nodes of a binary tree. In the following binary tree where it contains 7 nodes, D, E, F, G are leaf nodes where they are not having any children. The remaining 3 nodes they are having children. So A, B, C are non-leaf nodes and D, E, F, G are leaf nodes. Leaf nodes are D, E, F, G. Then A, B, C are non-leaf nodes where A, B, C are having children, D, E, F, G are not having any children. Right. Then we know how to traverse a binary tree. Traversing is nothing but visiting each and every node of a binary tree. We have three traversal techniques. They are pre-order, in-order, post-order. In all the three traversal techniques, we can visit all the nodes of a binary tree. Suppose if it is pre-order, the pre-order traversal is we visit root node, then we traverse left subtree in pre-order, then we traverse right subtree in pre-order. So we wanted to have the traversal of this binary tree in pre-order, then A, then B, D, E, C, F, G. Suppose if it is in order, in order, we traverse left subtree in order, visit root node, we traverse right subtree in order. So left subtree D, B, E, D, B, E, then root node A, then right subtree in order F, C, G. Suppose if it is post order, traverse left subtree in post order, traverse right subtree in post order, then visit root node. Left subtree in post order D, E, B, D, E, B. Then traverse right subtree in post order F, G, C, F, G, C. Then root node A. So in this way, we can visit all the nodes. In pre-order, we are visiting all the nodes. In order, we are visiting all the nodes. And in post-order also, we are visiting all the nodes. Then, the concept of tree traversal is very much similar to the concept of counting leaf nodes. That is, leaf node function is very similar to in-order function or pre-order function or post-order function. While visiting the nodes, we can check whether the node is a leaf node or not. We are visiting all the nodes in all the three orders. We are visiting all the nodes. That is, we are moving a pointer to every node. Whenever a pointer is pointing to a particular node, we can check whether that node is a leaf node or not by checking the left and right subtrees. If left is null and right is null, we can say that that particular node is a leaf node. So we may use pre-order concept or in-order concept or post-order concept to check whether a particular node is a leaf node or not. For example, let us consider post order. See here, post order P, where P is name of tree. Post order P, post order P. P is a binary tree. Then to traverse a non-empty binary tree, if P is not null, if tree is not null, traverse left subtree P left in post order, traverse P right in post order, then visit root node printf P data. Post order P left, post order P right, printf P data means traverse left subtree in post order, traverse right subtree in post order, then visit root node, that is L R V. To traverse a non-empty binary tree, we perform three things. First one is traverse left subtree in post order, then traverse right subtree in post order, then visit root node L R V. L R V. L R V. Traverse left subtree in post order, traverse right subtree in post order, then visit root node. So traverse left subtree in post order means we are calling the same function post order p left. If p is root node, left subtree will be traversed in post order. Then post order p right subtree will be traversed in post order. After completion of traversal of left subtree and right subtree, we visit p data. Visit p data, printf p data. Now this concept is used to count the number of leaf nodes of a binary. The function to count number of leaf nodes in a binary tree. Counting number of leaf nodes is similar to traversal of a binary tree. There are three different traversals: pre-order, in-order, post-order. For example, let us consider post-order traversal as a reference. Say post-order traversal. In a post-order traversal, we can visit the nodes of a binary tree in post-order. Like if it is non-empty binary tree, we perform three things. That is, first one is to traverse left subtree in post order, then traverse right subtree in post order, then visit root node. The same we perform here. See, post order P is a binary tree or a pointer pointing to binary tree, that is a pointer pointing to root. So binary tree root of a binary tree. Then P is not null, where P is root of a binary tree. If it is not null means non-empty binary tree. Non-empty binary tree. If it is a non-empty binary tree, we perform three things. Post order P left, that is traverse left subtree in post order, then post order P right, traverse right subtree in post order, then printf P data, that is visit root node. So to traverse a non-empty binary tree in post order, we perform three things. Traverse left subtree in post order, traverse right subtree in post order, then visit root node L or V. In this way, we can print all the values or we can visit all the no key values of nodes, all the nodes. So what could be the order here if it is the example? So let us consider the binary tree specified in here. There are 7 nodes. To traverse a non-empty binary tree in post order, it visits nodes in the following order: D, E, B, F, G, C, A, where a pointer moving in this direction, right? Like this, the pointer will be moved. So the pointer is pointing to D, then E, then B, then F, then G, then C, then A. So this is the order. In the post order traversal, we visit nodes. So at the time you visit a node, you check whether that particular node is a leaf node or not. When P is pointing to D, check. Is left of D and right of D are null? Yes. Yes. So count is 1. Count is 1. First time you checked that there is a leaf node. Then E. Then pointer moving to E. Is E a leaf node? Yes. So count is 2. Then you move to node B. Is B leaf node? No. Count is 2 only. Then P moves to F. Here you check whether F is a leaf node or not. Yes, F is a leaf node because left of F and right of F is null. So F is a leaf node. Count is increased. Count is now 3. Then P moves to next node G. So in the order, in post order, the P is moving to G node. So now is G a leaf node? Yes. Left of G is null, right of G is null. So count is 4. Then P moves to C. Is C a leaf node? No. So count is 4 only. Then P moves to A. What about A? Is it leaf node? No. So count remains as 4. So 4 will be passing to main function or calling function. So count of leaf nodes is 4. So we are using post order traversal in here. We are moving a pointer in post order traversal where first node is D, second node is E, third node is B, fourth node is F, fifth node is G, sixth node is C, seventh node is A. Everywhere when there is a pointer moving to a particular node, check if P left is equal to null and P right is equal to null. Is P left null? Is P right null? Means left side is null, right side is null. Then that particular node is said to be a leaf node. So the same post order traversal we are using to count number of leaf nodes of a binary tree. Instead of post order, we use leaf count. The same P is a binary tree is binary tree. Then count is, we are going to find count of leaf nodes. Count of leaf nodes. Initially, we assume that count is 0. Before moving this or before calling this function, we assume that count is 0. We are moving count value to leaf count, right? We are passing count variable formal parameter here. Then if P is not null, see, as usual in post order there are 3 statements. Here also there are 3 statements. Instead of post order we are using leaf count P, the same P we are using. Additionally we are using count of leaf nodes. So a variable to count number of leaf nodes. Then leaf count P left, while traversing left side of the node, left side of the tree, find count. Then while traversing right side of the node, find count of the leaf nodes. Then every time you visit a node, check whether it is a leaf node or not. How to check? If P left is null and P right is null, increase count. If P left is null, suppose if P is pointing to D, is D left is null? Yes. Is D right is null? Yes. Increase count. When P is pointing to E, is P left is null? Yes. P right is null? Yes. So increase count. When P pointing to A, is A left null? No. A right null? No. So count is not increased. Count remains same, right? So like that, P is pointing to every node. Whenever a P pointing to a particular node, P is moving to a particular node, we are checking whether P left is null or P right is null. If both are null, then we say it is a leaf node. Count is increased by 1. The only thing is, if P left is null and P right is null, count is increased by 1. Count is count plus 1. So in this way we can find the total number of leaf nodes in a particular binary tree. We can follow post order traversal or pre-order traversal or in order traversal, no issue. So using pre-order traversal, right, not only pre-order, the concept of in order also you can use, concept of post order you can use, concept of pre-order you can use, where while visiting we use if statement. If P left is null, P right is null, increase counts, right? So here also we are using 3 statements. L or we, instead of visiting we check whether it is leaf node or not. Thank you.